Alright class, we're going on to ellipses day 2. This is the opposite of what we did yesterday, where we were given an equation and we have to graph it and get all the parts. Now I'm giving you the parts and you have to go backwards. You have to tell me what the equation is. This actually can be kind of easier for people now that we know how the parts work with the equation. So what I like to do is graph it first to figure out my equation. So it tells me that the center is at 0, 0 for the first one. One of the foci are at 0, 1. Well, if you guys know anything about the foci, if there's a focus up 1 from the center, there's also a focus down 1 at the center. This also means that my major axis is in the y direction. And sure enough, one of the vertices is at 0, negative 2. Which means the other vertex is at 0, 2. So we have that. I know the focal length is 1, and I know Ry is 2. I also know that's going to be the bigger one because it's where the foci are. So we need to figure out what this other the co-vertice, I called it in the last video, where that is. So if you remember correctly, f squared equals big R squared minus little r squared, which is going to be our Rx this time. So 1 squared equals 4 minus Rx. So we get negative 3 equals negative Rx, so Rx equals 3. I forgot there's a square with these. Equals square root of 3. That makes more sense. So square root of 3 would be out 1.5-ish. 1.5-ish. So here's my ellipse. And now we can put that into an equation. Well, if the center is 0, 0, it's just x squared and y squared on top. Now we just need to figure out the radii. If Rx is square root of 3, that means when you square it, you get a 3 down here. If Ry is 2, when you square it, you get a 4 down here. That's all you got to do to come up with an equation. Figure out Rx and Ry in the center. That's all you need. Sometimes you need to put the focus down to get that. Alright, let's see this is kind of the same problem actually for the next one. I know my foci are at plus or minus 2, 0. So here's a focus. Here's a focus. Those are the foci. Now you guys should be able to tell me where the center is based on that, because the center is directly in between those two. And since the center is what's directly in between them is 0, 0, we have another 0, 0 center. I also know the length of the entire major axis, and by the way, the major axis will be in the x direction because the foci are always on that, is 6. So if I'm at the center and I need to go 6 total, that's 3 in each direction. So I'm telling you that Rx is equal to 3. I'm also telling you that f equals 2. So now we can find Ry. 2 squared is equal to 3 squared minus Ry squared. 4 minus 9 is negative 5 equals negative Ry squared. So you're going to get Ry, excuse me, Ry is equal to root 5. So that means that it's a little more than 2. And there's my ellipse. You can use different colors if you want. I'm kind of just keeping with the same one for today. Now we can write our equation. Again, the center being, remember when you have an equation, this is the ellipse equation. You have your center at top with the x and y. So in this case it's going to be x squared and y squared because, again, 0, 0. The x radius was 3, so when you square that we say that's 9. And the ry radius is net root 5, so when you square that you get 5. And there's my equation. Alright, let's do another one. Got a couple of these today. So this time, I tell you the vertices are at 2, 5 and 2, negative 1. And I tell you the focal length is 2. So first let's figure out where the vertices are. 2, 5 and 2, negative 1. Alright, that's the top and bottom of the ellipse. So we can find, and obviously the major axis is the y-axis because that's where the vertices are. We can find the center based on how long the major axis is. The major axis is 1, 2, 3, 4, 5, 6. So that means halfway in between would be 3 away. So my center is at 2, 2. I just did that by cutting it in half, using some symmetry. I also know f is 2, which means that if I go 2 up and 2 down, that's where my foci are. So those are my foci. It doesn't really matter, it's for graphing purposes, but really we need to find Well, we found out that Ry is 3, and we know that f is 2. So we can use our formula again. F squared is equal to the bigger radius squared minus, or plus, it's minus, sorry. Minus the smaller radius, in this case will be Rx. 4 minus 9 root 5, this will be another root 5 case for x. So that's 1, 2 and a little, 1, 2 and a little, and then we have our ellipse. Okay, there it is. And we have to come up with the equation. Now, it's a little different here. Now that the center is 2, 2, we have x minus 2 and y minus 2, both squared. Rx is root 5, so when you square that, that becomes 5. Ry was 3, the distance, the radius is 3, so we square that, we get 9. And that's our equation. Alright, we're doing well. So now we have a few other things. I have a center at 1, 2. A vertice at 1, 4. So right away, I'm telling you that Ry is equal to 2, and that's also the major axis. So if Ry is 2, that means there's another vertice at 1, 0. It also contains the point 2, 2. Well, if I pick 2, 2, 2, 2 is here. Do you guys see how that is right next to the ellipse center in the x direction? I basically gave you Rx. Rx is 1. If it contains the point 2, 2, it has to have that one, and we already have the ellipse. We don't even need to do anything with the foci because we don't need that for the equation. We need these two things. So now I can write my equation. In the x direction, I have a minus 1. In the y direction, I have a minus 2. Rx is 1. 1 squared is 1. Oh, by the way, I need an equal 1 over here. Y 2 squared is 4. That's my equation, and that's my graph. And then you could find the focal, you could find f, and then find where the foci are if you wanted to, but we're not going to do that for that one. So we also can model word problems with ellipses and come up with equations. So we have an arch in the shape of an upper half of an ellipse is used to support a bridge. So basically what that's saying is we have a river. Here's my river. We have an arch, and then here's the bridge, basically. Okay, so there's the bridge. There's cars going over the bridge. Right, that's a good car, right? All right, so anyway, we don't really care about the bridge, though. We care about this ellipse. This is in a half of an ellipse right here. That's why it's called semi-elliptical arc bridge. So the arch in the shape of an upper half is used to support. So we know that this whole thing is 30. The center of the arch is 10 meters above the center of the river. So we know that this is 10. Write an equation. Excuse me. Okay, so it says write an equation for the ellipse in which the x-axis coincides with the water level. So here's my x-axis. And the y-axis passes through the center. Well, that's telling you that this point right here is 0, 0, which happens to be the center. So the center is 0, 0. This is actually a simple problem. You guys see word problems and you freak out. This is probably one of the easiest problems I can give you. In order to make an equation of an ellipse, you need the center and you need the 2 radii. Well, if the whole length of the river is 30, wouldn't you guys agree that the x radii is 15? And then I told you the y radii. In the y direction, if from the center up, it says it's 10. So I have my equation. X squared and y squared on top. And then you square the radii. So 15 squared is 225. And 10 squared is 100. This would model that ellipse. And then you can use that to find different heights of the bridge if you wanted to. I just care that you guys get the equation. Alright. And finally, we have another one, a whispering gallery. I don't know if you guys have been to museums or if you've just been walking in a hall and all of a sudden you hear like echoes or you hear across the room. It's called a whispering gallery. And if you stand at the focus of a whispering gallery, you can hear someone talking at the other focus all the way across the room. They can whisper and you can hear them because all the sound travels from that focus to the other focus. So, Austin is standing at one focus of a whispering gallery and is 8 feet from the nearest wall. So I'm going to draw an ellipse. So here's one of the foci. So it's saying that he is 8 feet from the wall. So I'm going to just put 8 there. He is whispering about his Fortnite squad to Tyler, who is at the other focus 120 feet away. I tell you that this is 120 feet away. And by the way, since this is symmetry, this focus must also be 8 away. What is the length of the whispering gallery? Well, we basically just did that. 120 plus 8 plus 8. So to answer the first question, the length is just 120 plus 8 plus 8, which is 136 feet. And then how high is the elliptical ceiling? So we need to find basically the y radius, if you want to think of it that way. So this is just like a problem we did on the front page. I know the center. Well, I don't know it, but you can make the center anything you want. What's the easiest thing to make a center? 0, 0. So I'm going to say the center is 0, 0. So here's my center right here. If this length is 120, that means that this length is 60 here and this length is 60 here. So that means the x radius is actually 68, right? To go from the center all the way to the edge. It means that the focal length is 60. So I can use this to find Ry. So I get 60 squared equals 68 squared minus Ry squared. Now on a test you will not have a calculator. This obviously is a calculator problem. But like I said, on a test you don't have it, so I will give you a very easy word problem. You get the square root of 1024, which is 32. Great. So Ry is actually 32. Well, it says how high is the elliptical ceiling? Well, it would be the Ry. So that means that the second answer is 32 feet. So I just found that this is 32 feet up here. And that's it. That's how you can use the properties of ellipses to answer all these problems. Okay? You didn't even have to write an equation for this one. You just needed to find the pieces and answer the questions that were necessary. So, alright, those are ellipses. I will see you next time.